hopefully this will give you a bit of a break from studying and be entertaining today, because today we are going to talk about that most ancient of professions, which is that ever since people had money, there's always have been people who want to trick you into giving them giving them your money. What?
So the bank.
No, I'm talking about scammers. Banks are great places to put your money so that it won't get stolen, and then they pay you for keeping it there. That works. Banks are a great institution. However, I'm talking about scamming, which is that so we're going to today demonstrate a couple games, and what we're going to do is we're going to see that some games that look fair are more foul. They are not as fair as they seem. So, but we're going to start by first talking about that most important of topics, which is randomization. I mean, look, at the end of the day, calculus and all the other mathematics, they're a lot easier than they appear to be, believe it or not. They just dress it up in all this horrible notation, and they slam you with professors who have a terrible accent, you know. So, but mathematics, and when it comes down to calculus, I'm not great at playing. With calculus, what you've got is you're basically only ever learning three things. You're learning limits, derivatives, which is the question that asks, what exactly is the slope of a curve? And that's all it's asking. It's asking about rates of change. Okay, that's number two. Number three is integrals, which is what is the area that is underneath the curve, right? So, and it turns out that derivatives and integrals are kind of opposite operations of each other. So you learn one, you can kind of use the other to help you. Now, in Calc 2, I don't really know how they do it here, but typically you learn Taylor's theorem, which is basically a way of saying, figuring out this is hard, so we're going to learn a way to do we're going to teach you a good way to estimate it, and then we're going to talk about infinite series, which is the way that basically things grow as they, or rather, like what happens when we've got a term that goes to infinity, but the numbers don't really add up too quickly. If it goes all the way, I think it's Taylor series. Could be wrong. It's been a while for me. Anyway, but series, they converge. So like 1 + 2 + 3 + 4 all the way up to n, that actually has a convergence. So it's triangular numbers, which are actually very common. But when you put it in mathematical notation, it looks super scary. You know, you've got the sigma and everything. So that makes it automatically scary and automatically horrible. A lot of mathematics is dressed up in this horrible symbology. It's part of it is learning a language. So now, but with regards today, we're going to be talking about something that's a bit more philosophical, I guess, right? Which is, and I went ahead and turned it onto a lighter color scheme today because I like that a bit more. We're going to be talking about randomness. So let's see. So
want us to follow you via idle?
No, you don't really need to follow me. This is going to be fair. I'm going to just be discussing kind of something as we set it up. But more if you pay attention to this. So let's call this one flips.py. So what I'm going to do is I'm going to write something that you should be able to write at this point fairly easily. I will run the chapter in 9 and 10 graders. I thought I ran it, and for some reason, people are still reporting problems. So I'm going to run it again tonight. I'm going to do another bulk upload by tomorrow night at the best. Why is it saying? Sorry. Okay. Something went wrong with. Okay. Something went wrong with the IntelliSense support. So I'm restarting this. Okay. Now let's go ahead and import random. Now,
should we follow along with you?
You can, I mean, follow along in the sense of watching. You don't need to write anything for this. We're going to be playing a couple games. Okay. This isn't an in-class exercise or anything. This is nothing to panic about. This is kind of a sort of a lecture, but one we're going to have fun with. So let's go ahead and write a very basic function that I would hope you'd be able to do at this point, which is let's go ahead and write a problem that basically, let's write something that simulates a coin flip, which is given a, whenever we call this function, return head or tails, okay? And return it fairly, okay? Now there's a couple of different ways we can do this because of the way the random function works. We can do like something like this. Sides is equal to heads and tails. This is like partially the most straightforward way to do it, which is because it doesn't involve any math whatsoever. We say sides is equal to heads and tails, and then return random dot choice sides. And what that does is basically it says, hey, of the things in this list, randomly choose one of them, right? So if I were to print flip, so if I were to call this and run it, right, we would get heads, tails, right, heads. And of course, I mean, the only way I can really verify to you is to show you that this works, is to do a Monte Carlo approximation, which is basically to say, let's go ahead and basically, let's do 10,000 flips, or sorry, 100,000 flips. And then let's go ahead and count up all the heads that occur. So heads is equal to 0 for in range flips flip. Okay, if flip equals head, return, we don't need, no, we're not in a function, we don't return. We do heads plus equals 1. Okay. And then we will just simply print out heads divided by flips, which should be roughly 50%, right? This should be roughly 1/2. Flips. Okay, and it's not going to be precisely 1/2 because of randomness, right? Sometimes we're going to run 100,000 times, and it's going to be close to 1/2, but we're going to get, some inequality of heads versus tails. When you flip coins, you're never going to get, it's going to be very rare that you get precisely 1/2 and 1/2. I just created 100,000 just because that was a lot and it's enough to kind of demonstrate this. So how does random.choice actually choose though? That's a great question. And it's actually where I was going to go next, which is that everything in random works off of what's called the random function. So let's go ahead and, so what I'm going to do, I can just probably go in like this. Yeah. Okay, cool. So right here in the terminal, but you see that everybody sees this Python terminal that's running. It's a REPL just right there. It's pretty cool. So let's go ahead and import random into this terminal right over here, just to show you. Random has a function within it, which is called random, which is the basis for everything random does, I believe, because it's all you need. And if you can't guess, so if you're having trouble telling what it does, it's actually fair. It's actually as simple as it seems. It chooses a random number between 0 and 1. Now, remember, conceptually, there are an infinite number of numbers between 0 and 1, right? There are an infinite number of floats between 0 and 1. And if you don't believe me, think of the smallest number you can, like the smallest number that's greater than 0 you can, and then multiply it by 0.1. Now you've got something smaller. Conceptually, there's random numbers. Sorry, conceptually, there's infinite number of these things. So it gives us a great range. So how does it choose something? Well, let's go ahead and just rewrite this using random, not random. Okay. Which is that basically a coin flip, we want heads to be the result of half of these things and tails to be the result of the other half. So what we can do is say, hey, num is equal to random dot random, right? That gives me a float. And I'll say, hey, if num is less than 0.5, if num is less than 0.5, and it doesn't really matter, it's kind of inconsequential how small, which way it is. But like, again, random at choice just simply chooses something from a list given from everything in the list. Here, I'm just kind of manually writing what it would do, which is that it flips a coin and says, there's two things. So if it's less than a half, we're going to return H. Else, we're going to return the tail. Okay, so what do we do? And now we just run it again, and we kind of confirm that it's got the same statistical kind of deal. It's close enough to a half, right? It doesn't seem to be too biased, but we'd have to do more flips to tell. Okay. So what random not choice does is that when it wants to generate or rather, if I was writing random not choice, what I would do is say, hey, here's the length of the list. All right. So there's 5 things in the list. So I'm going to section off the results of 0 to 1 into 5 equal parts, right? So 0 to 0.2, 0.2 to 0.4, 0.4 to 0.6, and then I figure it out based off of what range that random number between 0 and 1 comes in. Now, I'm sure that leads into another question of, wait, how do random numbers get chosen in the first place? Right? And the answer to that is unsatisfying because it's kind of black magic. Because the idea here is that it's actually not a random number. Right? Because if computer scientists are anything, they're pedantic, right? In fact, if scientists are anything, they're pedantic. So, which is that, like, well, what is randomness anyway, right? Like, okay, suppose I've got this 6-sided die here. Suppose if I were to give you basically the ambient wind speed where I'm around, the amount of height I'm going to throw it at, the distance it's got to fall to hit my desk, and the amount of spin and velocity I'm going to apply to this thing, would you be able to calculate how this thing landed? Is that actually a random kind of event? Right? Or is it just kind of predetermined? And we just don't know the variables for that. Right? So, and same thing with computers. Computers use a form in order to generate something that's random. We use a pseudo random number generator, so pseudo random meaning looks like random. Specifically, right? So here we go, pseudo random number generator, right? Which is also called a deterministic random bit, is a sequence for generating numbers whose properties approximate the properties of random numbers. Long story short, we've got basically something like, let's see, there's a bunch of different ways to generate stuff. I believe the most popular one is the Mersenne twister. Says it's the default generator in Python, which basically it uses math and it uses a lot of just math to generate these things. It uses a whole lot of just kind of information that's kind of sitting there that's unimportant on the computer and hard to reproduce to figure out to get a random number. Some things you can do to get the random number is like use the current time in milliseconds since 1970, which is how most computers actually tell time. CPU time, not that one. System time. Idle time, steal time, system time. Let's see. Ah, yes, system time represents this. So, for example, Unix and POSIX compliant system, e.g. if you're using a Mac, it counts the number of seconds elapsed since the start of January 1st, 1970, which is the Unix epoch, which is the amount of seconds that have elapsed since 1970, minus leap seconds, because those are a thing, because those are awful. Keeping track of time actually turns out is actually a really tough problem, like especially when you care about difference in seconds. So these are all tough problems. But going back to this, to like the problem of randomness, we kind of just throw up our hands up in the air and says, fine, if it looks random, it is random. And so when we say we're generating random numbers, we're meaning it's statistically distributed as random. All right, but I promise this would be fun, and that did not sound like fun. So let's go back to fun. All right, so we've got a function here that generates a random coin flip. All right, so let's go ahead and play a game. All right, a coin flipping game. Okay, so does anybody want to play this game with me? We're not going to play for money or for anything, just a game for learning.
I will.
Okay.
I was going to volunteer.
All right.
Yeah, I'm down.
Steve. All right, so let's go ahead and establish some stuff, right? If I were to flip a coin 3 times in a row, right, there's 8 different possible outcomes, right? We've got head, 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 tail, head, tail, tail, not has attribute, head, tail, tail, head, let's see, head, tail, head. Yeah, let's do that. So those are our 4 things that could possibly start with head. And if we start with tail instead, it would be tail, 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 head, tail, head, tail, and tail, head, head, right? Those are the 8 possible outcomes you can get from throwing a coin, right? You agree with that?
Yes.
All right. So yeah, and I mean, there's no trickery here. This is you throw 3 coins, right? Each of them has 2 possibilities. So 2 possibilities times 2 possibilities times 2 possibilities. That gives you a grand total of 8. This is just basic kind of statistics. This is not where the scam is, by the way. Okay, the scam is in the rules. Okay, so let's talk about the game. So the game is that we are going to flip coins until one of these 8 sequences comes up. Now, all these 8 sequences are perfectly likely. So say you choose head, head, tail, tail, right? If basically we flip coins, head, tail, tail, right? You'd win this one because head, tail, tail came up before my choice, which might be head, head, head. Make sense? So say I choose head, tail, head, and you chose tail. So suppose I chose tail, head, tail, and you chose tail, tail, head, right? What I'll do is that we'll just simply generate numbers until one of them wins. Make sense?
Yeah. Knowing my luck, usually would go head, tail, tail.
So now, because you're playing the game, because you're new to the game, I think it's only fair that you choose your sequence first. So, since I can't choose whatever you choose.
I'll go with head, tail, tail.
Head, tail, tail. So you're going to choose head, tail, tail?
Yes.
Yeah. Okay. So I'm going to go ahead and I think I will choose tail, head, tail. So, all right. So let's go ahead and see which one of us wins by writing basically this game. Okay, so def game. So let's go ahead and play a game, and let's see. So we're gonna get sequences player 1 versus and player 2. Okay, so player 1 sequence and player 2 sequence. This game is actually fairly well known one. And in case you haven't figured it out, the cheat is the fact that I made him go first. So that's where the scam is. The cheat is that I made him go first. But wait, they're all statistically the same. They occur with the same level of randomness, right? We'll get to that. Scams are rely off of being having an unintuitive trick. So what we're going to do is that we've got our outcomes.
It reminds me of why I always go second in chess. I always play back in chess.
Outcomes is equal to, so these are our flips. Or maybe I'll just call it sequence, because this is our sequence of flips. Yeah. We'll just call it our sequence of flips, and it's just going to be a list. So what we're going to do is we are going to generate our first 3 flips. Okay. So we're going to generate 3 flips first, which is because we need to seed it, right? Nobody can win unless there's been 3 flips. So for blank in range 3, and this may not be the best way to do it, but I don't care. It's the way that is the easiest way for you to see. We're going to do sequence dot append. Oh, right. No, easiest way to do this is actually to turn sequence into a string. Okay. Or that way, that will make it easier. So sequence is a string. So, and then we'll just simply say sequence plus equals flip, which is our coin flip, right? It will return either heads or tails. So this will end up with 3, right? With one of these 3 outcomes. Let's go ahead and get rid of that so that we don't get an error. Okay. So now let's go ahead. So we've got our sequence here that we've added to. Now what do we need to do? While, you know what, I'm just going to say true because I'm terrible like that. While true, if the last 3, so if the last 3 things of the sequence, so from -3 to the end of the sequence equals player 1, return 1. I'm going to return 0. I'm going to return 1 to say that player 1 won. If the last 3 things in the sequence are what we care for, are what we got from player 1, if that matches what player 1 does, then he's going to win. If player 2, on the other hand, if that's what matches him, we're going to return 2. Okay, to represent that he wins. Either of those will break out of the for loop. This is just simply the slice for the last 3. So for instance, here we are in Python again. So let's go ahead and I will just simply say string. So word is equal to, so at the bottom of this window, word is equal to hello. Right, word going negative indexes in Python goes from the end. So this gives us O, L, E, L, and then E. So going -3 slice like that gives us 3 to the end. It's a super useful notation that's kind of unique to Python. Enables to do stuff like get the last 3. So otherwise, if nobody won, we need to flip another coin and add it to the sequence. Okay, so now for range in, so we're going to do games instead of flips. Let's go ahead and But actually, before we Monte Carlo this, let's go ahead and actually now call this to see what happens. So print game, and let's see. So Steven said head, tail, tail. And I'm going to say tail, tail, head. Wait, no, I said tail, head, tail. That matters. Oh, I don't have an else there. I deleted I deleted that. My bad. So I deleted that when I undid. So let's go ahead and run it. So player 2 wins. That's me. Let's run it again. Player 1 wins. Hey. Oh, player 2 wins. Player 1 wins. We're evenly matched, right? Oh, I guess not
more.
So much.
9 more.
Guess not so much. What in the world is going on here? All right, let's go ahead, in fact, see, and let's, in fact, the game is now rigged in my favor. Let's go ahead and see, and then we will see why. All right.
I won 3 out. I won 3 out of the 10, so
let's go
30%
ahead.
chance.
So obviously the way to tell if something is rigged is to simulate it multiple times, right? Because if it was really a fair game, it'd be 50-50. So let's go ahead and say games, and let's go with wins for counting the number of times player 1 wins is equal to 0. So games is equal to head. So if if game, so all I need to do is just switch this to match what the outcomes were. So if game is equal to 1, I don't know what it says. All right, game, and I need to give it these arguments. So if game is equal to 1, then wins plus equals, not wines, wins plus equals 0. So now I have to print out wins divided by games. It didn't take too long at all to kind of just check what the outcome to check. So it says you won actually half the time. Did I do it right?
I'm pretty sure that was not half the time.
Wins out of games. Looks like you are winning half the time, which is interesting.
Maybe the game wasn't rigged. Who knows?
Maybe it wasn't rigged. Let's see. Head, tail, tail. And then I should do.
Because if I remember correctly, you won
I don't
3
think I meant.
than me.
Wait. So let's now let me try this one though.
I'm going to see the cat.
Oh, that's a little better.
That's a bit more rigged, shall we?
That's in more time of what we were last time.
Wait a second, but all 8 sequences come up at the same rate, right? Like if I flip 3 in a row, these things are all equally likely, right? So the answer, what I'm doing here is I'm creating a sequence that kind of will subsume your sequence. So let's go ahead and take a look at your possible outcomes. Your possible outcomes is that if I flip heads, tails, tails, that will win for you. But if we start by flipping any number of heads, anytime but anytime we get 2 heads in a row to begin with, I'm going to win no matter what, right? In fact, anytime we see 2 heads or any number of sequence of heads, as soon as a tail is thrown, I win. On your hand, on the hand for you to win, you need head, tail, tail, or you need a sequence like this: head, tail, head, tail, head, tail, and then for another tail to be thrown. But as soon as there's 2 heads, I'm going to win because of the way your sequence is. Another sequence, and actually I can do this for pretty much any sequence you use. if you choose, for instance, I'm going to go with 3 heads in a row. I'm going to choose to do tail head, which actually should be really lopsided, I believe. Oof. Because the only way you can win is by throwing 3 heads in a row from the beginning, which only has a 1 in 8 chance of occurring. Because anytime this happens, for you to win, you need to do head. You need to do 3 heads in a row. But for you to do 3 heads in a row, my sequence is already going to be in there. Unless your sequence won in the first place, in which case we would never get a tail in the first place.
Yep.
Same thing happens with tail, by the way. If you choose tail, all I'm going to do is I'm going to say I want head, tail. Laser, I need you to not be frustrated with that. I know you wanted to see the cats turn evil. He is playing he's playing Bowser's Fury with his mother. This new Super Mario game that came out last month. All right, so and actually, so the trick is that this is something called Penny's game, and the trick is that whatever player won, the scammer always goes second in order to win. And the trick for this is that the scammer creates a sequence that if the player doesn't win outright, then his sequence will subsume the other sequence. And we do this with a simple trick, which is that if you choose 1, 2, 3 as your sequence, I'm just going to choose not 2. I'm going to choose whatever not 2 is and then do 1, 2. Not 2, 1, 2. So if you choose, so in other words, if you choose head, tail, I'm going to choose whatever not 2 is. So 2 in this case is the H. That's the second thing in your sequence. So I'm going to go T, and then I'm going to do HH, which is your 1, 2. So I'm going to pretty much ignore your third choice. And let's see how that one works out. I think this one actually is more fairly balanced. Let's see. I believe this one is actually fairly balanced. Nope, totally not balanced at all.
1/4 chance.
1/4 chance of winning. Okay, and you say you get smart. You're gonna go ahead and choose tail, head, and I'm just simply going to go and choose. So not 2 is T, then 1, 2 TTH, which is 1/3. So I can always choose a sequence that is gonna beat yours.
Just gonna say, just out of my experience, I don't think it's ever a good idea to choose your, like, if you're in a like game like this, ever choose whoever the other person does, because usually just leads you down a rabbit hole.
Yep. So Penny's game it's just fun because you can completely dominate somebody in this game. Let's choose another game. Let's do another game. We're not limited to just coin games. But let's actually stick with the coin game for right now, which is that, so here's another kind of thing you might see if somebody's targeting you while you're particularly inebriated for some reason, right? So moral of the story is don't bet money. By the way, moral of the story of this is don't play bar games because someone will be able to beat you. Just by taking advantage of your inability to think properly. So, right, let's go back to this flip function. This flip function says half a chance of getting heads and tails, right? So, so heads and tails, even odds that you're going to be able to get 50%, right? Even odds that you're going to get heads or tails. Okay, so here's my proposal. Flip 10 coins. Get 5 heads and 5 tails, right? 50-50, right? And the chances of getting heads are 50-50. Chances of getting tails are 50-50. So obviously, your chance of getting 5 heads and 5 tails is 50-50, right? That's a lie. But the idea here is that he's going to say, okay, you get I get $1 if you lose, but if you get if you win, you get $1. So it's all all fair because even odds for everybody involved, right? So what are the real odds to this game? So the sequence we want to get is, so let's go ahead and write this. Def, so let's write this game. We're going to call it 10 flips, right? So we want to, so the objective is to get 5 heads and 5 tails, right? Again, we're going to just simply do a sequence here as our output. Sequence is equal to blank. And this time we'll just return our sequence because that might be useful for seeing our analysis. Did you find the cats?
Yeah, I found some cats.
Okay, we'll see if they turn evil now. So sequence is equal to, I don't know why he wants to turn cats evil. They're all, they can already be quite temperamental. All right, so 10 flips. So for a 4 blank in range 10, we're going to do 10. Let's see. We're not starting the dogs better than cats fight here, or cats better than dogs. I love my furry friends all equally, let's say.
We all know reptiles are better.
No. Takes reptiles can be cute. I do like axolotls. They are very adorable. All right, so we've got 10 flips. So let's go ahead and take a look at our sequence. Our sequence is, we're going to do plus equal flip. So right, flip heads to tail. So our sequence is going to be like heads, head, tail, head, tail, head, tail, right? So we're just going to get a string of length 10 that has randomly distributed, heads and tails. Okay, so let's go ahead and get rid of this. Let's see, edit. Toggle block comment? No. Edit, we're going to type, ooh, that's cool. Control slash, and I can just, boom, all commented out now. So let's go ahead and do the 10 flips now. So what we want to do for the 10 flips is simply say, how many games do we want? We want 10,000 games. Let's do this 10,000 times. That should be enough to show whether or not we are being scammed. My wife cannot stand spiders. If there's spiders that need to be taken care of, I need to take them all. So, which is not great because I'm not the biggest fan of spiders too. I just seem to have the normal human kind of reaction to any kind of creepy crawly thing as opposed to, 4 blank in range games, which is 10 of them. Spiders though, if they're in a web, we kind of let them be because they're getting rid of other creatures. But if they're like creepy crawly spiders, that's the issue. All right. So 4 range and blank games. So we're going to play this 10 flips game. Right. And we're going to and how do we tell if we win the game? So wins, we need 5 heads and 5 tails, which we can just simply say if 10 flips, that returns a thing. So if that returns a string. So if that gives me count of H is equal to 5, right? So if 10 flips and we count the number of 8 heads in there, if that is equal to 5, then that's a win. Because if there's 5 head, we don't need to check for tails because if there's 5 heads, there's 5 tails. We just kind of know, right? 10 minus 5 is equal to 5. Right? We're not going to do hard math here. The computer does all the hard math. Sounds like you're having success over there, Annie.
I'm up to 14.
Ooh, at 15, you'll be able to fight Bowser as that like Super Saiyan giant Mario cat. I don't know. Mario's gotten weird, and I love it. Wait, actually, Mario's never stopped being weird.
Mario has become more anime, and it's fine.
We're all fine with it. Mario's the best.
I've always been a tiny bit more of a Sonic person.
That's fine. Sonic is perfectly fun too. So we played this game and it turns out that you're only winning a quarter of the time. What? You're winning a quarter of the time, but he said it was 50-50.
Maybe it's because you were flipping a quarter.
Oh, that. You know what the difference between a bad joke and a dad joke is?
The dad jokes is in here.
Do you know what the difference between a bad joke and a dad joke is?
You don't see it coming.
The letter B. Hmm.
I'm dead.
I'm dead.
so dead.
I'm just gonna go lay down. I just got killed.
I've been telling, so first off, as a dad, I am like, I've got like, I think they sent me a card in the mail which says I am allowed to tell dad jokes. Second is that is basically, I think I was telling dad jokes even before my kid was born. So the punchline was the difference between bad jokes and dad jokes is the letter B. Okay. So, but yes, we are winning a quarter of the time, it seems. So we need to, so let's go ahead and what we can do here is, because we're returning the entire sequence, we can actually do this. We can actually look at this a bit better. We can take a look at the wins and instead change, and what we can, instead of counting the wins, well, in addition to counting the wins, we can also count the outcomes. Right. Oh yeah, that scene from Crystal Skull. Ugh.
Not even that. That gives me it, but it's also just in my aunt's house. When she first got her house, there was a hole that they didn't know that ants would go through every time it was raining. The whole entire kitchen was covered in ants, and I refused to go near it.
We're dealing with ants right now. So let's go ahead and do what we're going to do is we are going to do 10 flips. Okay. Now for the sake of simplicity, we are going to go ahead and we are going to sort the outcome. So we're going to sort the string so that it's alphabetical order. That way we can count a bit better. So outcome is equal to sorted dot 10 flips. And now we can just simply count the outcome. Or let's call it sequence because sequence is equal to this. Sequence. Okay. If sequence is equal to 5, wins plus equals 1. Now, why sorted? Because there's no real difference between head, tail, head, tail, head, tail, head, tail, head, tail, and then 5 heads in a row and 5 tails in a row. There's no difference between them. So we're going to be basically combining, by sorting them, we combine all those. So if sequence dot count the number of heads, again, that's going to be equal to 5. And what we're going to do is we are going to also say, hey, if the sequence is in the outcomes, have we seen this sequence before? Then we're going to say, hey, outcomes plus equal, or outcomes of that sequence plus equals 1. So we've seen that one more time. Else, this is the first time we've seen it, so we're just going to simply say we've seen it once. Okay, so now we can print, not only do that, we can print, not only print out the wins in the games, but we can say, hey, for sequence in sorted outcomes dot keys. So this basically says, hey, all those outcomes, sort them, please. So, and then I can go through them in order and then print out the sequence, the outcomes of that sequence. And then sequence. And then we can take this and say divided by games for the percentage. So these are dictionaries, right? Basically what this is doing is saying, hey, these are lists where I get to make up the index. Okay, so watch the videos on dictionaries. Yeah. Basically all I'm saying is, hey, if we've not seen the sequence before? Well, I've seen it once now. If I have seen the sequence before though, increment the number of times I've seen it by 1. And this just simply is a fancy way of printing out all that information. Unhashable type list. It's sequence. Oh, it turned it into a list. Ugh. What about sort? So this turns it into a list. Okay, which is not fun for me. So it turns it into a list. Ugh, I hate having to do this. It'll always look so ugly. That turns it back into a string. There we go.
Got the 15th. I beat the one with switches.
All right.
Once I realized that.
So here's our outcomes. So all heads and all, so we get, there's a ton of different outcomes that can happen. Hey, wait, no, come back. Ah. Here we go. Okay. So here's our outcomes, right? And we notice that while 5 heads and 5 tails is the most common outcome, it only comes as a quarter of the time because getting 6 heads or 4 heads are also very likely outcomes, right? It's because when you flip multiple coins, there's multiple different outcomes than just heads and tails, and each of them have their own chance of occurring. Now getting 10 of one type and only of one type is obviously very rare because in fact, it happens. The chances of that happening are 2 to the 10. Because so that's actually, so while it seemed fair, the logic he was using was deceptive. All right, so now let's go ahead and talk about, but enough about coin games. There's only so much we can do with coins. After all, everybody knows that it's cards where the real scams are, right? So
They always are.
yeah, so okay, this one's called 7-card hustle. All right, I'm gonna go ahead and grab 3 red. I'm gonna get 5 red cards at random from the deck. Sorry, 5 red cards. All right, 5 red cards. And I'm gonna get 2 black cards, right? Can't have a 7-card hustle without 7 cards. So 5 cards. So 5 red cards and 2 black cards. I'm gonna go ahead and shuffle them. And what I'll do is that I will just simply lay them out in a line, and then I'm gonna pick you guys up and kind of just be very annoying like that. So 7 cards, right? So here we go. We've got 7 cards, even though 7 cards. Now the idea here is, can you turn over 3 cards at random? Can you turn over if you turn over 3 cards? Whoops. This is so tough to do that. All right, so there we go. Can we turn over 3 cards at random so that they are all red cards? And as you can see, that did not happen for me. I mean, after all, seems fairly straightforward to just get 3 red cards, but it's not. right? So we've got 5 cards. Sorry, so we've got 7 cards here. We shuffle them, we lay them out into a line, right? And you got to just turn over 3 red cards at random, right? It's better than even odds for you, right? Because each of the steps is better than even odds, right? If you flip over your first card, right? Statistically, your chances of it being red are 5 to 2. 5 of the cards, right? So that's better than even odds. You pick one of them, 5 to 2 chance, right? And that's completely true, by the way. Right? And then after all, the chance of getting the second card to be red is, well, there's 4 red cards left and 2 black cards. So it's 4 to 2. Whoops. There goes my scam cards, and they're going 4 to 2, right? And then 3 to 2. All those chances are better than even odds. So obviously, the entire thing is better than even odds for you. Now, of course, the scam here is that while each of those individual steps are each of the individual steps are favored towards you, the combination of all 3 steps are rigged against you because you have to do 3 steps. You have to win all 3 of those tries, not just one game. So let's go ahead and do this. Let's go ahead and calculate this. 7 card hustle. Okay, so we're going to go ahead and do quite a bit of this stuff. Def 7 card hustle. Now there's a bunch of ways we can simulate this. A couple different ways we can do is that we can just basically create a, regardless, what we're going to do is that we are going to create a list of, cards, or we can create a string. Honestly, strings are easier to deal with. So let's go ahead and say our deck is 7 cards. So, and we need to generate, actually, it's going to be a list. Yeah, this will be better. We need a deck of 7 cards. So we need 7 red cards. Sorry, we need 5 red cards. 1, 2, 3, 4, 5. 7 red cards and 2 black cards. Right? 5 red cards, 2 black cards. Okay, that's what we got here. Now, the easiest way regardless of which way we do this, the next step is that we're going to use the random method to shuffle it, which is super simple. It's just got something called shuffle inside of it, which is fantastic. And what that does is that it does what it says, exactly what it says on the tin. It shuffles it. Now, before I completely forget, and before I continue with this, I realized that I did not discuss this, and I kind of need to. Around this time, last semester, we started doing different activities, different tracks for the students in this course, and that turned out to be like a terrible idea. So next week is going to be a bit of a bye week for you guys, where we start talking about the various things for the project. Okay. So we're going to talk about the different things that you can do for the project. So this lab, right, you're getting the pig lab, which is going to be a big lab, but I didn't want to forget this. So you're going to get this big pig lab that we're going to do. And so what we're going to do over here next week is that I'm going to teach you about GitHub, and I'm going to talk to you about doing your project proposal. Not your proposal, your proposal, which is your brainstorming activity, kind of thinking about where we talk about all the different things you can do for your project. Your GitHub lab is just basically, can you use GitHub, which is not hard. This is not a very hard lab. This is meant to be a super easy lab, basically a free 100 points. So keep that in mind. I also have to adjust the due dates of these things, of pig and the proposal, but that's okay. After that, I will be basically kind of keeping this up Yes, that's a start to creating your own repository. I just accidentally locked my screen by hitting the lock button. Oops. Okay. So, then there's going to be suggestions over here on how to do stuff, but I'll be going over other things that I've been asked to cover, like recursion, big O notation a bit, and some, as well as just like in general, just useful things to know. But also I'll cover things like game engines and I'll cover a bit in the way of game engines and how to make a game, both graphical and non-graphical. You can still make some very good games that are not graphical. It's a good place to start if you want to make games. And then also I'll keep these up, but I'll not make them worth any points because they are useful knowledge. Notice that this part is unpublished. So yeah, you can totally do machine learning and object-oriented programming. Object-oriented programming is, we talk about that in the next class, 1068, that Professor Fiore goes over. All right, but anyway, the point is that next week, right? I know you're all busy this week, so next week's next week will be week 10 is going to be a bit of a breather week for everybody. You're welcome.
I need it after this week. of
Hey.
research.
Most definitely. I gotta take care of those quizzes though.
You do have to take care of the quizzes, but
Those
you
are
know, you can do
due-
them at any point and you're not learning anything new for the quizzes. They're over file reading and dictionaries respectively, I believe.
They're due next Sunday, correct?
Oh, I don't keep track of that.
Like the 28th and the 30th.
One's next Friday and one's next Sunday, I think.
Yeah, I tried to give you some time on those. Plenty of time. They just got to get done by then. Right. And I'm going to be pretty hard on the deadline for that. So if you can't complete them in time, send me an email telling me why you couldn't complete them in time. Like, you know, you caught COVID or something. So
The 28th and the 31st. Okay.
So let's go back to creating our cheaty face game. So 1, 2, 3, 4, 5. So this just will shuffle our deck and let's see, does it change it? It says, so shuffle takes in, it returns nothing. Shuffle, it shuffles it in place. Okay, so it shuffles it in place. So it will go ahead and swap around everything. So now we need to, so we can do this in a couple ways. We can figure out what is the winning sequence by just basically drawing the same 3 cards, which is like the first 3, and seeing if that wins. Or we could, you know, randomly remove cards from this thing. Either of those work, but honestly, just taking a look at the first 3 cards, that seems to be as likely as any other cards. So so let's go ahead and basically say our selection is, let's go with the first 3 cards because we can just do slice notation for that. Deck 0 to 3. First 3 cards. If and now if B in, if I'm still so used to being able, it's this gap. I'm so used to being able to like cross over my right hand to type the B. So if B in selection, we're going to return false to say that we lost. Return true to win, right? That makes sense to everybody? We take our deck, we take the deck, the random deck of cards with 5 red and 2 black. We shuffle them up and we ask, okay, we're going to grab 3 cards. We're going to grab the first 3 cards from it, right? Otherwise, if it's in selection, great. If there's a B in there, if we drew a black card, we lost, but otherwise we win. So let's go ahead and comment this out again, or comment this all out. And let's go ahead and do this one. So, again, games, let's do 10,000 of these games, right? If we play 10,000 of these games, if we observe 10,000 of these games, we obviously should be able to see the outcome. So, or to see if it's rigged, right? Because the guy's got to make money in the long term. He can afford to lose a couple times for this game. That game can't be unwinnable. Nobody's going to play a game that they obviously lose all the time. No, that's not true. People play Dark Souls all the time.
Dark Souls, the masochist.
I love Dark Souls. Dark Souls is one of my favorite games of all time. I'm actually fairly good at it, but like people identify that as a really tough game. So it makes it a topical humor. All about that topical humor. Wins is equal to 0. 4 blank in range games. Yeah. It's just time blocking. It's just timed attacking and blocking. It's not that hard. All right. So wins. Okay. So we're going to say if 7-card hustle. So if 7-card hustle equals true, wins plus equals 1. That's all we really need. And now we just print out the wins ratio. Wins divided by games. So how badly do we do? We win only 28% of the time, 27% of the time, 28% of the time. Maybe if we try more games, maybe we'll get better at this. No, we're still doing terribly at this game. Okay, maybe our method is flawed, right? Okay, so we're always choosing the first 3 cards. We're not actually selecting cards, right? So maybe if we actually choose cards at random, that might be good. So let's go ahead and go back to our random function. Maybe there's something in there that will help us. And this is, so let me pull it over here, random. Okay, random.choice. Ooh, random.choices. All right, return a case-sized list of elements chosen from a population with replacement. Interesting. Okay, can we do this without a sample? So with replacement wouldn't be good because we'd keep drawing and putting it back, right? So instead, what we want is, random.sample. Returns a k-length list of unique elements chosen from the population sequence or set, used for random sampling without replacement. You can also do other stuff with it, like sample red, blue counts 4, 2, 5, which is equivalent to saying red, 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 blue, blue, and choosing 5 of those from it. So that's cool. We could have done this in one line, which is really nice, but we're just going to go ahead and do this. So rather than doing that, we're going to say random. Instead, we're just going to do random dot sample, which is going to grab. We're going to grab from the deck 3 of the things, assuming I can spell random instead of radom, which is the lesser known cousin of radon, obviously. Instead of making you dead, it makes you unable to spell. So selection random.sample 3. So, and then we say, hey, if it's in selection. So obviously, since now we're selecting a random sample, we're doing exactly the same. So it is completely rigged against you. Now, why is it completely rigged against you? Well, because while the game is 5-2, while your chances are 5 out of 7 in your favor, right? Better than even odds for the first game, and 4 out of 6 in this next game, and then 3 out of 5 in the final choice, right? The way statistics work is that these are not independent events because they're all part of the same game. So since they're all dependent on each other, you have to win them all. You have to multiply those. And if we decide to multiply those all together, let's go ahead and if we multiply those all together, like here in Python, we get 28%, 28.5%. So it turns out we are being scammed. Now, for the record, actually, so let's go ahead and actually, so it's 3:10. So you're still here. So let's take a look at an exam from last semester. Sorry, from not last semester, but from the exam, an actual exam I gave, in the before times, prior to COVID, when I would actually hand out exams on paper. Okay. I know, what a weird concept.
Feels so much long ago.
I know, the before times. All right, let me see. Is that the exam? I only want to show you certain things from this. All right, so this was my question on the actual exam too, of my exam, which I gave out, which was, this is the Monte Carlo paper, Monte Carlo exam question. I'm going to leave this to you kind of as a practice. You don't have to turn it in for credit, but if you want to do something, this is kind of like what I would give you for your final exam. Now, before I completely scare you by those words, final exam, the only difference between taking a final exam and a quiz is that we're all taking the final exam at the same time. And the final exam will be on Canvas so there's 3 differences. First, we're all taking it at the same time. Second, it's going to be on Canvas rather than on Runestone. And third, you're going to be logged into Zoom, but I'm not going to really be proctoring in the sense that I'm going to be looking at everything you do or making you install Proctorio or some other really overly intrusive
open
stuff.
book?
Yeah, it's open book. Don't care. I mean, look, unless I can give you I'm going to be frank with you. Unless I can get you in the same place at the same time physically, so we can actually see what you're doing, and also so that there's also peer pressure against, not using resources that you shouldn't, I can't really prevent you from cheating if you're in your room. There's nothing stopping me from stopping you from having like some weird stuff behind your screen or attached to your monitor or wherever. Like you're resourceful. People are resourceful. They can, if they want to cheat, they can figure it around. So the best I can do is kind of just,
It reminds me of last semester in one of my friend's classes. He showed the teacher after like the semester was over where how he was cheating. He had like things duct taped to the top of his roof, so every time he would need help, he just looked up.
Right. I mean, there's nothing stopping me. Like it's a losing battle. So I just simply make my exams in such a way that I'm thinking the same thing, but I create the exams in such a way that basically that you're allowed to use online resources. Yeah, that's another great point. Ryan points out gets a great point. I mean, if I'm coding, I have 2 monitors. If I'm actively coding, I typically have a window devoted for my coding. Then half the other window is devoted towards basically any kind of documentation or Google searching I'm doing. And then the other half is kind of like for, music or other entertainment. So I've got it split up. but having an extra window so I can look stuff up is an active part of my thing. You're never coding basically with just your brain alone. You've got to use resources that are available to you. So I give you the resources available to you. The resources that I would expect. Now, that being said, there are like kind of there are reasons to not to also against like why on paper I might give you a paper exam. One is that on paper you aren't like constantly testing your code and trying to figure out that the reason, trying to figure out why it's not running when it's just a spelling error. The paper doesn't care about spelling errors. But on a computer, you're going to lose 15 minutes trying to figure that out. On paper, you're not going to even notice, and you're going to just keep going. And chances are I'm not going to notice because it's a dumb spelling error, or I'm just not going to care. So that's also why that there's only so few questions on the final exam. So it's to be fair. Okay, so let's talk about this problem, which is of a class of the stuff you are going to get in your final exam. Again, I'm going to repeat, for the final exam, guaranteed one of the questions worth a third of the final exam grade is basically going, here's the rules of a game or parts of the rules of the game. Please do a Monte Carlo of the outcomes. So here is Monopoly, which is a very famous game, right? The players move around the board by rolling 6. So we're only caring about movement around the board here. Specifically, we're only caring about one part, which is the rolling of the dice. We roll a pair of 6-sided dice. Rolling doubles, such as 2 3s or 2 5s, that's great because, as anybody knows, you get another turn, essentially. You get to roll again and move further. If you roll another set of doubles, right, which can be the same pair as the first time, this gets you yet another turn. But rolling 3 doubles is bad because because you're quote unquote speeding and you get thrown into jail. So, and then you get trapped in jail until you can roll a double. So write a program that simulates 100,000 Monopoly turns. Extra rolls due to doubles count as the same turn, right? Even though it's an extra turn, it all happens on the same turn, right? So it simulates where a turn is a single roll of the dice or more if the user rolls a double. Your program should print out the percentage of rolls without a double, the percentage of rolls with 1, percentage of rolls with 2, percentage of rolls with 3 doubles. Now, this was a 20-point question, which seems a bit scary, but for all the questions that you will ever have on a final exam or something like this, I will break it down. Points will be given as follows. Simulating 100,000 dice rolls, then 5 points for handling doubles, 3 points for handling 2 and 3 doubles in a row, and 2 points for presenting the data as percentages. So long as, and this kind of also tells you the order in which you need to achieve stuff. Now, some people just left this blank, which is a shame because this was essentially a free 10 points over here. How is that free 10 points? Well, let's go ahead and see. Def, roll 2d6. So this is to roll a 2-sided die. Result is equal. So we're going to just simply return what? Yeah, random. Sorry, yeah. How do I generate a random number between 1 and 6? Right, spend 1 minute Googling, right? How do I generate a random die of a 6-sided die? Okay, recognize that you need 2 of them. So that's all you need to do. And in about 1 minute of actual work, if we've generated a 2-sided, so we've done some amount of work, but now we have to simulate, says simulate 100,000 of these. Count to make sure that I have the proper number of zeros, right? Because I'm on an exam and that means I'm super cautious. So I've got 100,000 here, remove that 0 to make it legal. And now just simply say my roll is equal to roll 2d6. Okay, that's 10 points. Right? And so then 5 points if we handle the doubles. So that's basically saying that, okay, So maybe now I need to redo this because I care about what the results are and if they're equal. So instead I'll just do 1d6 and we'll do roll 1 is equal to 1d6. Roll 2 is equal to roll 1d6 as well. So each of those, so I'm going to roll 2 6-sided dice. And now to handle the doubles, I basically just got to ask if roll 1 is equal to roll 2. Make sense? And so then I got to continue on and count those up. So I like this question a lot. Let's see, did I have anything similar on the final exam? Nope, I did not have stat on the final exam when I was writing that. But this is the kind of stuff that I would ask on a final exam for this time. Last time around, I did one of Laser's games. So yeah, that was but there's a third of your exam. Another third of your exam will be something we learn after this, which is regular expressions. So it's going to be after our break week. We're going to probably cover regular expressions because regular expressions are the things that basically make everything super easy when it comes to parsing text. The question I like to ask is, here's a file. It has a bunch of social security numbers in it. Please remove all the social security numbers. Regular expressions make it so you can do that in anywhere between 1 and 7 lines, depending on how you decide how big of a one-liner you want, or if you don't include any. So typically, second question is, given a file, I need you to remove personal information from it in a specific format, be it emails. Last semester, it was Temple email addresses. So anything that started TU letter, number, and then the @Temple. So, and then the third one is always something that something that basically that it's going to be the first time you're exposed to. So I evaluate basically, can you do text parsing? Can you manipulate text? Can you do file reading? Can you do if statements all in one question? We do the Monte Carlo, which does another thing. And then the final question will always be something that you've never been exposed to. So that tests how well are you able to learn new material, which is part of what we're teaching you to do in computer science. But it is going to be something that's new to you, but it is built into Python. So there's going to be tons of So I will literally link you to the documentation page. So those are the 3 questions I plan on asking on the final. Other questions before we terminate class?
Professor, a while ago I sent you an email saying that I caught up with all my Runestone reading assignments.
Oh,
I don't know if you saw it though.
I did see it. I just didn't reply because I'm going to be running. So I will be rerunning all the Runestone Grader today because I typically wait a week before I do the full batch. And then I will upload to Canvas again.
Yeah.
Okay, so if you've done your work since then, you'll be counted. If you get a 0 because you haven't done it yet, then don't worry, it's going to get caught in the next batch.
All right, thank you, Professor.
All right. I don't really have time at the moment to handle demos, but if you need to, and I moved my office hours tonight. My office hours will be in, I'm not sure. Ask Professor Fiore. My office hours are going to be, I moved them to tomorrow. So I think they're from noon to 2. So if you want to sign up for office hours, then that's good. Or if you need a demo, send me an email and we can arrange a time to demo. But I can't cover demos because I realized I have not had lunch and I need to fix that. So
I have a question about the pig assignment.
sure.
When is the due date for that? Is it the same as what's on Canvas right now, or is it later than that?
I will adjust that due date. It should be a bit later. That one takes a bit longer. And people seem to be a bit, people have informed me as of the beginning of class that they are very busy right now. So I will give you more time.
Okay, thank you.
Okay. All right.